This lesson is going over why we rewrite negative exponents, and it's also going to explain why anything to the 0 power always equals 1. So we've kind of gone over it already, but we rewrite negative exponents as a numerator of 1 and then the denominator as our base with a positive exponent. And the reason for that being is because we never want to have negative exponents. So if I write the expanded form of it, x times x times x, over x times x times x times x times x. We know that anything, numerator and denominator of the same thing, divided equals 1. So I'm using the 1 from the previous lesson. Here's a 1, and here's a 1. Well, what can I put on top? That's not going to change anything. Multiplying everything by 1. So 1 over x squared, which again is the same thing as x to the negative 2, because 3 minus 5 gives me a negative 2, which is what I have right here, but we know that we have to rewrite it as a positive exponent. So anything to the 0 power is 1. Any whole number to the 0 power, any fraction to the 0 power, any variable to the 0 power always equals 1. Well, why is that? And the reason for that being is because in the first example, I'm going to rewrite it out as the expanded form. So x times x times x over x times x times x. Now, again, going back to the giant 1, this is a 1, this is a 1, and this is a 1. So 1 times 1 times 1 is 1. But we also know that when we divide, we subtract the exponents. So x to the third minus 3 equals x to the 0 power. Well, x to the 0 simplifies to be a 1 because everything ends up canceling out in a sense, or simplifying down to be a 1. Same thing with the second example I've given you. You have 3 over 3, which simplifies down to be 1. But then, more importantly, your exponent, your 6 and your 6, you're just going to have x times x times x times x times x times x over the same thing. And again, it's just going to all simplify down to be 1s. So, because it's all 1s and 6 minus 6 is 0, it ends up just equaling 1.